We've got three guys from Technomics today, Paul Harden, Tyler Staffen, and Alex LaRusso. They'll be discussing the 1921 maintenance and repair parts data report, along with two topics that have been particularly popular with ICEA members in the past few years, R and data analytics. Guys?
Yeah, well, thanks so much. And thanks to all who have been able to call in today and hear us. Before we get going here, I wanted to just say we're really excited to be able to share this information, not only the new reporting requirement that's been out there that's very helpful, but also the fact that we, not only on this project, but have more and more been using this advanced data technology or data analytics kind of technology. And it was it was just very exciting to be able to use that to create this prototype environment to help us do our job better and to really see the value of this data more clearly and to be able to share that when we were going through this lessons learned study. So just to start with, I'm going to give a background about myself real quick, and then I'll let Alex and Tyler introduce themselves. So my name is Paul Harden. I started at the Naval Center for Cost Analysis back in 1991. I worked briefly at OSD Cape. In 2001, I joined Technomics, and then along the way, I've done a lot of work in the operating and support cost area. I've developed numerous methods, done special studies for the Navy VAMLOS program, developed a number of tools, and have worked with OSDK in recent years and trying to improve VAMLOS, especially working with OSDK over the last few years, working with Lisa Mabley, who was the technical lead for the MR effort. So worked with her quite a bit as we were trying to develop improved data requirements. And it's through that effort and what we were able to do there that resulted in us developing this paper. So with that, I'll let Alex and Tyler introduce themselves.
Thanks, Paul. Good afternoon, everyone. I'm Alex LaRusso, and I've been at Technomics since last summer after graduating from Penn State with an industrial engineering degree. For the past year, I've primarily been working on cost data analytics and developing estimates for a couple naval and other shipbuilding programs. And then more recently, I've been involved working in data analytics for some ground vehicles as well. This is my first time being part of writing an ICEA paper, and so far it's been a great experience. So I'm looking forward to sharing it with you all.
Good afternoon. I'm Tyler Staffen, and I'm a senior associate at Technomics and also a graduate of Penn State. Similar to Alex, most of my work has been focused in EVM, data analytics, and cost estimating. This is now my second year being involved in ICEA-related research efforts. I want to say thank you for attending today's presentation, and Paul's going to now get us started with today's discussion.
Yeah, thanks, Tyler. In terms of the purpose of the paper, it's kind of threefold. Our main objective was to increase awareness in the community about this maintenance and repair reporting capability that's now available so that we can get what we need from contractors in terms of the right level of data. But then the other purpose was in what we did through that lessons learned study, we were able to utilize and leverage some of the more advanced data analytics technology. In our case, we had been using R on other things, and we're currently, use it now, trying to develop an EVM solution because we support the subworld in terms of all the EVM analysis. But it just happened to be the one that our group was using, so we picked that one. But within our company, we use Tableau. We also use Power BI, and for different customers, so we're familiar with that as well. But then the other purpose of the paper, other than getting some introduction of that kind of technology and discussing the value of that, we also wanted to kind of cover and show the value of the MR data itself, and do that through showing a demo or doing a demo of the actual MR dashboard or the prototype that we built as we went through the study. So next slide. Did you already change it? The slide? Okay.
Yep.
sorry about it. So anyway, over the past few years, like I said, we were working with AFCA as well as OSDK to do a number of improvements in collecting more detailed data. The main focus of that was in collecting better technical data, because without the right technical data, you really can't make the best use of the cost information that you're collecting. So from that effort, there was a technical data report that was created that can now be used to improve the kinds of information you need, depending on the contract or the activity they're doing and what the contract's including. So not only for acquisition is there technical data that you can now select and request, but there's also a number of technical data that we developed that's related to sustainment cost. In doing that, we were working with the different government organizations, the service VAMOS systems and OSDK, trying to revisit the ONS work breakdown structure, really think about the influence of drivers of each cost element and the kind of technical data that we're used to seeing we can get out of our VAMOS, service VAMOS systems, but that data that we really need to get to make use of the cost data. The other thing to mention here is since about 2012, that's when the sustainment CSDR kind of came into being, and we started collecting this kind of data. It's been over the past 10 years plus that we've had more contractors that are really managing and supporting our weapon systems. It's over that period of time that we've had this gap develop in kind of getting the same level of detail information that we're used to managing ourselves and having it as part of our organic data systems. So in some ways we're using OSDK is trying to fill that gap. They're trying to collect what we should be getting and help supplement the service VAMOS systems. So in one case we had developed a technical data report, which is a great value. But then we wanted to collect this more detailed maintenance repair parts information that we're just simply used to having. And it's really hard to see how you can estimate future programs correctly, even when you're dealing with like a modernization program, having it the right amount of detail to understand what's happening in that part of the system to assess how changes might occur and what my new cost estimate should be. But even with that, if you're a contractor, you're managing a weapon system, you're responsible for understanding if there are any issues, what's causing my cost, what's my demand, what's the impact on availability. I need to have enough information in that environment to know where I might make investments to improve, reduce costs, improve availability and performance. So this data that we're asking for is something that contractors should have. And in the study that we done, we found that for the most part, all of it is known by the contractor and could be reported. But it's also data that you want to have as a part of being a program manager and being able to understand what's happening with your program. And also without that data, you can't understand what's going to come down the road, because you may change the scope of your contract that you want, that you need for next year, the year after. So understanding what it costs for different things is important to understand that as well. So once we had developed the MR, in late 2018 is kind of when we started getting some of this data reported to us for a couple programs. One of the programs was the Army Shadow UAV program. It's in that program that we kind of teamed up with them, and we said, let's conduct this lessons learned study. And it's in that environment that the real objectives of that was to look at real data coming in, finally, try to use our V&V process that we had created to validate the data and see if the process and the checklist and the things we said, this is how we're going to do the V&V, to see if that really worked, how easy that was to do. We also wanted to check the data for any issues in terms of just kind of misunderstanding in the definition of the data fields, what we're asking for versus what we're being given. And then the last thing was we really wanted to try to use the data in an analytical environment and do real analysis. That way, that would help us confirm the value of the data, the things you could do, and to share that back with the program office. So in doing a lot of those things and trying to do them in Excel, we found it very tedious. You know, we were having to, for every checklist on the V&V guide, we were having to kind of create a separate tool, you know, or sheet that was doing calculations. So that was okay, but there's a lot of ideas that developed in being able to see how we might automate some of that and put it into more of a dashboard environment. And that's what we kind of finally did in terms of trying to assess the value of the data. We said, well, let's leverage this our Shiny technology, and let's, instead of trying to create the same stuff in Excel, let's create a dashboard that's just a better environment, a more automated environment to drop the data block in, with the idea that, you know, it could be in the future that this is leveraged. So that's what we did. And that was very helpful in trying to really assess the data, not only the value of it, but to even spot check the V&V aspects of it. So next slide. So like I said, the MR is one component of the CSDR system. There's also the technical data report. And the other thing is, you know, the sustainment phase can represent 2/3 of your cost, and probably half of that 2/3 can be maintenance related. So it's just critical that we really collect this information. And like I said, it's, you know, even if you're a program manager, even if you're the contractor, you really need to have this kind of information to understand issues, cost, and know how to affect performance and control costs. And I mentioned that unless you get the data down at this level, it's hard to develop these improved cost estimating techniques. That we typically can get that kind of information out of our BAMA systems where we have that data that we manage organically. Next slide. Sorry. Okay. So in terms of the content of the MR report, there's basically two tables of information. For example, in dealing with the Army Shadow program with their data they were submitting Excel files, and it was monthly. So one sheet in the Excel file would have the maintenance event report information, and then another sheet in the Excel file would have the repair part report information. So with the maintenance event kind of data, we're collecting for each unique event. We have a row of information. On that row, we have columns of data. It's in by each maintenance event. We kind of track. We want to know, if we can, the end item, the specific end item. So this could be a tail number, a specific aircraft or ground vehicle or whatever. But also we want to track the variant, because with Army Shadow there's two variants, and as you have more variants, you want to kind of compare and contrast what's happening as you make changes to the system. And of course, it's important to break out the information by scheduled or unscheduled kind of activities or events, and getting the right kind of failure information to know the reasons for things, why they're happening. And then start and completion date is important to kind of relate to availability. And in terms of organization location, there are some programs and contracts where you might be doing maintenance at different locations, and you may be doing the same kinds of activities. So in that case, if you were able to compare and kind of benchmark those experiences to each other, you might find areas where one place is doing it a lot faster. You might, try to focus on those deltas, look for efficiencies, and kind of try to learn from the different locations. One example of using that kind of information. In terms of maintenance events, there could be many types of maintenance events within a contract: overhauls, repairing DLRs, inspections. So knowing what kind of event type it is important. And that also kind of then relates or correlates to the ONSWBF, so that you can kind of relate this activity at the more detailed level back up to the 1921 cost report. And then finally, we attempt to collect the labor hours for each maintenance event. And then on the right side, we have all the part information. So for each maintenance event, we could have multiple parts that are either replaced or repaired, and we want to know the details of that. So for each part, we might know the repair action code or description. But the other thing that we can do with this data that's really critical, important, and valuable is the fact that we can map these, with these codes, we're able to kind of then group the information into parts of the system or parts of the UAV. So in other words, we ask for a mapping to the 881, so relating each part to the product-oriented structure of the system. We also ask for the work unit code or functional working group, and that allows us to bucket the information into parts of the system. And as I said before, that's really needed if you're going to kind of drive down and focus on a given part of the system, because maybe there's an upgrade or a modernization activity or program that you need to estimate. And then finally, we get the replacement and the repair cost, which provides that kind of standard method or approach that we do where we look at repair costs as a function of replacement cost or unit cost. And also these metrics, those kinds of ratios are very useful when you want to do V&V of the data or look for consistency or see if things jump out that don't make sense. And those things are kind of part of the checklist that we had put together to do the V&V. Next slide. So I'm going to hurry up because I want to leave you guys with time. So the main output of that study was we did come up with a number of recommendations, which resulted in the contractor kind of correcting some data. So there was data improvement. We also took a lot of the lessons we learned and updated our documentation in terms of the guide, the brief. And from doing this, which Tyler's going to show in the prototype, we were able to kind of create an environment to better show the value of the actual data. So next slide. And just for more information, you can go to the OSDK website. At the website, you'll be able to download the latest implementation V&V guide or the training brief, and so you can find that information there. And just other, I mentioned Lisa Mavely, who is leading this effort, but also Sandy Inter is a very good resource. She's the subject expert for the sustainment reporting at CADE. So with that, I'm going to hand it off to you, Alex, to talk about R.
Thanks, Paul. So to understand the second half of this presentation and get into the actual building of the dashboard, let's first get caught up to speed on some background information. There's a variety of tools that we can use to get insight from data. We know that Microsoft Excel is still the default platform used for most analysis within the cost community. However, when working with and analyzing certain types of data, there could be more suitable options such as R. Recently, R has become a preferred data analytics solution in the cost community and in the greater sphere of data science as a whole. So I'm sure you all have been hearing through many different ICEA seminars, including the fantastic Flex file presentation from our very own Technomics colleagues last week about the different ways that it can be utilized. And if you didn't attend last week's seminar, I'd also highly recommend taking advantage of the archived recording on ICEA's website. There's a lot of great information in that. But today we'll only cover some of the main features of R and how we use it to provide deeper insight into MR data. The high-level overview is that R is a free language and integrated platform developed for statistical computing, data manipulation, and advanced graphical display. Since it's free, open source, and has a strong global community, new features and capabilities are added and refined on a daily basis. And there's a tremendous amount of resources, documentation, code examples that are made easily available that really make it easy to learn and work with. The R platform is made up of many different specialized packages. And now some of these packages, including the base library, are essential for R to work, but many other packages can be installed to expand on the core features of the language. Most R users are familiar with the RStudio Integrated Development Environment, or IDE, which is basically an application that simplifies working with the language. But the team behind RStudio didn't only create the IDE, they developed a number of well-maintained packages with quite a heavy user base. So one of the packages that we will go into more detail about here is Shiny. A quote here from the chief scientist at RStudio, Hadley Wickham, says that Shiny allows you to take your work in R and expose it via a web browser so that anyone can use it. Shiny makes you look awesome by making it easy to produce polished web apps with a minimum amount of pain. So after hearing that it would make us look awesome and it wouldn't be painful, we were sold. So we started learning more and more about it. We mentioned earlier that it's a package and something about seeing it in a web browser, but what exactly is Shiny? And what does it let you do? The package lets you create dynamic interactive dashboards in R by building applications that are made up of simple user interface or UI side, a server script, and then the underlying data that you want to show, but without you needing to know full stack web development or consider yourself an app developer or anything like that. But the dashboards are still fully customizable, and they let you make an environment designed to get greater insight into your data with very simple interface. Tyler, do you want to go ahead and talk about setting up a UI and a server and what that looks like?
Yep, sounds good. All right, thanks, Alex. So for those of you who are particularly familiar with web development, as Alex was just talking about, the Shiny apps are made up of two main components. So you have your user interface or UI, and then you have your server side. So simply put, the UI is really just going to be everything that the user sees and interacts with on the dashboard. So back to web development, like what you see built with HTML and CSS on a website. Now on your UI, you're going to see objects like your dropdowns, your buttons, your inputs, as well as your boxes, dynamic plots, and many other graphical features that you can code to your specification. Now looking at the server side, that's mainly going to deal with the backend code that accepts user input and then responds accordingly. Now the great thing about Shiny is that anything that you can calculate in R can be performed on the server side, whether that be particularly for data processing, fitting models, generating visuals, and more. Shiny really lifts R and brings it beyond its base capabilities in order to make it a lot more interactive, but still provide the same powerful backend and analytical tools. So as you see in the diagram at the bottom left, the UI and the server mainly go back and forth to just exchange some information. So when you're building the app, it really makes sense from the start to really build clean code to reduce the risk of confusion during the construction process. So usually you'll have one or more inputs that determine some sort of output response with your app. The reactive workflow of a Shiny application can really be tailored to any specifications that developers want, and then more importantly, the needs of the user or the analyst. For those of you who have experience with Shiny, you've probably seen that it's pretty standard convention to modularize the components of your applications. So when I'm building Shiny apps, I usually have multiple scripts that govern the workflow. So usually that's keeping the UI and the server separate in two different scripts, maybe having your background processing or calling the different directories that you're using to pull information from. Maybe you're connecting to a database. We usually like to keep those separate since it just simplifies the workflow. And then we have an additional run script that's going to call both of those, all the scripts that you're going to use, knits it all together, and then displays it in the web browser. Now, as you're building scripts, for those of you familiar with coding, some of these scripts do get pretty long, especially with how the UI is structured. You're going to end up having tons of lines of code if you're building a pretty advanced dashboard. So it makes it really easy to kind of make sure you understand what's going on by separating some of those features out into different scripts. Ideally, since you're going to be building UI and server side really at the same time, since you have UI interacting with the server, I tend to also split those up into maybe two different screens or two different windows, which makes your life a lot easier when you're under the development process. Now, Alex talked about R consisting of a bunch of different packages, and one of the packages that's provided by RStudio is going to be the Shiny Dashboard package, which really simplifies the development of Shiny applications and provides a bunch of additional functions that include panels, tabs, sidebars, and much more. By default, if you go and build a Shiny app, you're actually going to be presented with just a blank screen in the UI. So if you're really trying to build a dashboard style of application, the Shiny Dashboard package is going to make it pretty straightforward, at least more so than it would be if you were just left with a blank screen. So of course, with any software like this, there is a bit of a learning curve involved, but once you experiment with your first few applications, the process really becomes pretty repetitive and straightforward. A lot of the apps that you've made, you can really leverage to build new apps with. So with all that in mind, why did we go with R and Shiny specifically for this prototype dashboard environment? I'm going to turn it over to Alex to discuss some of the key requirements that we have for this project.
Thanks, Tyler. So the goal here was to build a tool that highlights the importance of the MR data, translating those data-rich reports into something that's easy to digest and where you can interact effectively with meaningful information. So while designing the dashboard, we came up with a list of requirements, and all of these requirements are satisfied by making a Shiny dashboard. Number one, a key component of the dashboard that we wanted was that we wanted to explore the data starting at a high level, and then based off of what you see from a high level, be able to dive into the data set to identify specific cost drivers. Basically, the intent was to have some flexibility by not limiting the levels of data detail that you can see. So it's not uncommon for visuals to only provide these high-level views that show you something really important, but to get more information about it, you have to go back and search the data set. This dashboard needed to provide like a fast, simple way to search the data set while still in the dashboard environment. And Shiny provides a framework for showing high-level and low-level views in the same place. It essentially becomes a one-stop shop for the entire analytical experience. Two, while there are certainly ways to customize graphs and charts and such in Excel, we found that there is this point of limitation, and you may hit that point pretty quickly. It's the point where the font of the data labels is perfect, the color scheme matches your company's branding and everything else you want, but that type of arrowhead that you want on your line is not on the short list of arrowheads available. And this might seem really specific, but in Shiny, that point of limitation is much harder to reach. Every aspect of the visual can be tailored, and the code behind all the visuals is designed to allow for an incredible amount of customization with easy accessibility. Next, the dashboard had to show visuals with varying levels of detail based off of user inputs. So, we said the visuals are designed to start at a high level, but we want to go lower and lower as more of these user inputs are specified. In an application such as Excel, each added layer of filtering is likely to complicate the setup or worse, hinder the performance. But R is highly scalable and ensures that graphics are rendered dynamically and efficiently, pretty much regardless of the size of the underlying data set, set it up correctly. Four, if these user inputs are so important, then they need to be intuitive and easy to use, preferably with buttons, drop-down menus, rather than manual text entry or changing formulas, anything like that. And Shiny has a lot of pre-coded functions that allow for a variety of different inputs, all of which are clean and work very similarly to each other in setup. If you know how to do a drop-down, then you know how to do radio buttons, then you know how to do everything else. Next, these can't just be pictures of graphs. So R supports cutting-edge data visualization with powerful graphics. It's easy to zoom in and out, change the graph region, reveal hover labels over each point, export visuals into multiple formats, and all of these features happen instantaneously without dramatically impacting the rendering time. Being able to interact with these visuals as you're performing analysis greatly improves the analysis process, and it really transforms the entire analytical experience from viewing static pictures of graphs in a slideshow to interactively engaging with the data. And lastly, perhaps most importantly, the dashboard needed to be as dynamic as possible while still maintaining speed. So each input triggers intensive manipulation of the data set that is then rendering interactive plots, and these have to be instantaneous, or else it really takes away from the experience and makes you not want to learn more about your data. We think that the environment shouldn't be the limiting factor in how quickly analysis can be performed. And this is really Shiny's bread and butter. It's backed by R's powerful computing capabilities, and the entire framework is designed to allow for everything to be dynamic without significantly sacrificing speed. And in the Shiny dashboard, there is a greater ability to strategize when those calculations occur and design it in such a way that will result in ideal performance. So you can code to load or not load things based off of what tab you're on in the dashboard, or wait until certain inputs are changed. So you're not trying to do too much all at once. And basically, the user isn't left staring at the bottom right of an Excel workbook, watching to see if it's still calculating. Everything is quick and snappy, and it makes it a lot more friendly to use. With those requirements understood and seeing that our Shiny checks all the boxes, Tyler is now going to walk us through how we set the dashboard up.
Thanks, Alex. So we're going to start out now with an explanation of the data set that we use to within the writing of this paper, and then we'll dive into the prototype dashboard environment. If you've seen the brief prior, you'll have seen static screenshots, but we're actually going to go into the web browser and see the interactivity that you get from Shiny. So as Paul mentioned earlier, originally the research was based on actual Department of Defense MR data, but we built a mock card data set to illustrate really how the MR and technical data reports would look within a prototype Shiny dashboard environment. So this dashboard makes it very easy for program managers and analysts to really dive into maintenance and cost drivers for whatever program that they're interested in. Now, for example, in this case, let's say a program manager might be interested in comparing maintenance events and cost drivers between the automatic and manual variants of a vehicle to determine in the long run which option is going to be more cost-effective and sustainable. Now, well-reported and thorough MR data can really simplify this process, but the data really must be analyzed and leveraged in an effective and proper manner. Otherwise, it's not really worthwhile. So the dashboard environment was constructed to really work with any MR data set, so replacing the actual DoD program data with a big data set was very straightforward. We prepared a data set we felt best represented the MR data, and that would be, of course, straightforward to understand. So let's dive into some of the main variables used in this dashboard, which you see up on slide 14. So the variant is going to be your top-level overarching category. As I just mentioned, those two variants are going to be your automatic and manual variants of the vehicle. Just think of any kind of car that you can get in either an automatic or manual transmission. That's going to be your two different variants. So the next level down is going to be your functional working group, or FWG, which is going to bucket each of the sections of the car into another higher level category that all contain parts of a similar function. So think of this maybe as your key systems like electrical, your braking, your exhaust, your body, all things that really work together to perform a specific task for the car or serve a specific function. Now the lowest level of the data that you'll see in the data set is going to be the specific part. So that's going to include your items like the battery, the pedal, the fender, your exhaust manifold, all those little parts that map back up to one of the discrete functional working groups in the data set with no overlap. So one part is going to go to a specific functional working group. You're not going to see it in other functional working groups. So your next variable that we're going to take a look at is going to be the event type, which is going to mainly just correspond to the type of maintenance event. So those different events can be routine maintenance, a modification, an accident, inspection, wear, and then just general malfunctions. So pretty much anything you'd call your mechanic for to fix. And the failure code is going to be a 3-digit number that's going to correspond to, of course, the type of failure that the vehicle is experiencing. So when you're driving your car and you receive an error message up on the dashboard, like the check engine light, your mechanic can run more specific vehicle diagnostics to hopefully pinpoint the exact problem. Then you have the schedule status, which is going to either label the maintenance event as either scheduled or unscheduled, whether you got to an accident, whether you're planning an inspection or whatnot. So those are the main categorical variables that you're going to get in this data, but of course, it comes with a bunch of different numeric variables. So the ones that we take a look at and identify within this dashboard are going to be the period at which the maintenance event started, the repair part quantity for that event, the total labor hours, the replacement cost and repair cost, and then of course, the total cost of the maintenance event. So now, as you can see, between what Paul was describing and looking a little bit more detail into this data, you see that there's really a ton of information that's packed into these MR reports. So really the main goal of this dashboard environment was to simplify the data analysis down to a level that's actually digestible. So let's switch over to a browser to go look at the dashboard prototype. All right, so you should be able to see the dashboard up on your screen. So we're going to take a look at this first tab. Let me just close out the sidebar just to make it a little bit bigger to see. So on this first tab, you're going to notice 5 panels right away. So 2 of them, the ones on the left side, are going to be your user selection panels. And then the other 3 are going to show different various views of the data. So the top control panel really just corresponds to the ones on the top, and then the control panel on the bottom is just going to control the one, that bar chart that you see on the bottom. Now, I can easily start out by just filtering to the different variants and schedule statuses just by clicking through these buttons. So you'll see I can go down to the automatic or manual variant of the vehicle. And then same thing for scheduled and unscheduled statuses. Now, you might want to have it in this view if you're interested in looking at a comparison between the 2 different variants, but you might specifically want to be looking at maybe just one of those variants, just looking at that data over time. So specifically, you have 2 different plots that you're going to see on the top. You're going to have your demand view, and you're going to have your cost view, where you have the ability to really change the different variables that you're interested in looking at. So you'll see that if I go over to the demand view variable dropdown, I click on this, I'll have a few different options that fall underneath it. So you'll see that I can calculate the total number of events per unit, per drive hour, per trip, and then of course the total number of units. And because of the awesome interactivity and speed, as soon as you click on it, you'll notice that it instantly is going to go render the image that you want and provide your data in a very clean fashion to you. Now on this right side, if I wanted to look at the same variable, I could go in and look at cost per unit. I could also go to the other ones, such as my drive hour, my trip, the total cost per event. But right here, this side-by-side view is particularly useful because now I can say, okay, maybe I want to see over time how many units I have out on the road of a specific variant. But then you might want to see, well, even if there are maybe more models of variant out there, maybe the maintenance costs are cheaper. Maybe over time those maintenance costs change. This kind of view will really allow for that, as well as being able to look at the cost and demand views for some of those other variables that we mentioned, like the drive hours, cost per trip, per event, etc. Now, as the backend data set is going to increase in size, so let's say you get data for a few months down the road, the nice thing about working with R is that it will instantly go and integrate the data into the dashboard, so you don't have to worry about whether or not the range of the data is appropriate, if you have to make any changes to kind of how the document's looking to make sure you're incorporating everything. All of that really gets handled automatically in the back end within R, so you really only have to worry about one thing, which is just analyzing your data. So another great feature of Alex, he was talking about some of the interactivity components that you get with the dashboard. So if I go and hover over some of these data points, you'll see I can identify that particular value that you have associated with that variable, the X and Y axis components. I can go in and zoom in, which is a really nice feature if you're just trying to look at one specific section. I can also go in and change my scaling of the graph. So maybe I want to look at just a specific few months and then just, hover over those data labels. Now, if you're putting together some sort of presentation and want to actually download those plots, it's great because you can just click the download plot button and it will download right to your downloads folder. So definitely would recommend going through and experimenting with the different options that you have within Shiny. These are only a few examples that are provided by the Plotly package, which is a JavaScript type plotting package that we use for its interactive features. There are a ton of different options out there, but we felt that this would be pretty much the easiest way for us to get the kind of interactivity we were looking for. So now if you want to go look at the bottom one, the bottom plot is going to be our total level view for the different maintenance cost and maintenance event drivers. So you'll see I can also go in and filter my different my variant types in automatic and manual, which is really nice. And then same thing, I can go through and click between the scheduled and unscheduled statuses, but maybe I want to keep these bucketed up at that top level. So you'll see that it goes in and automatically sorts it in descending level. And if I want to look at some of those other categories that we mentioned, instead of just looking at the functional working group, I can go down to that part level. You'll see there's a lot of different parts that show up here. I can really zoom in and identify maybe which ones have the highest amount of cost, which one had the most maintenance events. I can go and dive in really into all those different variables that we discussed on that last slide, and then be able to filter between which driver I'm looking at, whether that's total maintenance events or total costs. Now, of course, this is a fake data set, so you might see bumper has the most total cost and the most number of events. That might not actually be reflective of what the data actually would look like, but just a good way to just look at kind of how the data would be structured if you were going to use another real data set. So now, if I want to go move on to the detailed data tab, this really takes all this information and provides a little bit more of a robust view. So I'm going to come up here and then just move on to my detailed tab. And very similar view. We built the dashboard to look similar across the board. And as we go and expand new features, we want to make sure pretty much everything is easy to control in a very similar fashion. That way it makes it very easy for the user, which is really the end goal. So like that first part, I can go and filter by my variance or schedule statuses, but this is going to give me a little bit more insight into some of those metrics that Paul was talking about earlier. So you'll see that right here, I have all of my different functional working groups ranked by the total number of events, as well as some other metrics that you might want to leverage for further analysis. Now, because Chinese dynamic, if I wanted to go in and change which of these variables I wanted to look at, I could go in for, say, maybe I wanted to look at which one had the most repair cost per event. I can go in and do that, and then you'll see it'll shift that over to that second column, and then it'll go re-rank the variables accordingly, so I can identify that as the main variable that I want to look at. Now, instead of looking at functional working group, I can also look at the part level, and I can also look at some of those other categories like the event type, the failure code, all of that. Now, because Chinese dynamic in nature, if I go in and select the functional working group, I have this ability to select from here. Well, maybe I want to identify under interior which of those parts are really contributing to this high repair cost. So if I go to this drop down, you'll see it gives me the option to go through and select any of those different functional working groups. So let's say I want to pick interior. You'll see at this level, these are going to be your main cost drivers in terms of repair cost per event. You'll see that glove box actually comes in as the highest one. Again, this is not indicative of real data. This is just just a good example. Hopefully your glove box isn't the most expensive thing to repair on your vehicle, but at least it gives you the feel of kind of how this looks. And then if you want to go in and change the ranking variable, you can do so as well. You'll see it'll go in and resort your variables accordingly. So the great thing about the Shiny dashboard environment is very customizable. So we can expand a lot of these, make them more detailed, perform a lot more statistical analysis type features. Really great environment for a person who's working in cost analysis, and it really wants to get the best feel for the data that they can in an interactive way. So the main next phase of the dashboard is to help with the V&D process that Paul discussed earlier, which is a great way for us to systematically catch some of the errors within some of these selected reports. Additionally, we want to expand on some of these deep driver capabilities to look at other categories like the work unit code, logistics control number, or maybe some of the MIL standard 881 with its elements as well. And would also like to expand the dashboard environment to encompass some more of the data from the MR report that Paul had mentioned earlier. So now, with all that, I'm going to jump back to Paul for some concluding thoughts.
Yeah, thanks, Tyler. Let me see when the slide comes up. I'm just going to go to my version real quick. So just in summary, hopefully we were able to provide, some more awareness and show how critical it is to collect this maintenance and repair data from contractors, that it's both valuable to the cost estimating community as well as program managers. And then hopefully you got some feel for this data analytic technology with R and the capability of it. And I think, as Tyler mentioned, not only analyzing the data, but using that kind of environment is really good for doing V&V on the data. So keeping up with the technology, trying to really exploit it more, and do more with our data is essential for the community. And one of the things that's not really talked about that much that we're experiencing ourselves is the idea that you don't, this just isn't created automatically. Even, number one, there's the coding and kind of needing to know how to do it. But what's more important than that is being able to design what you really want to see. You need to, it's just as important to know what the problem is, what I can do with the information or the data, what questions I can answer. And then once I kind of know that, the influences, you still need to design that information in terms of what's that environment going to look like, what's the functionality, what I want to see here, what I want to see there. So that's kind of the real fun part, and it's great to be able to work that kind of design effort in a team of folks. So that's all we have. Hopefully this was provided some useful information for you, and we're happy to answer any questions you have at this time.
Well, Paul, we haven't gotten any questions yet, so you guys can take a breather while I turn it over to ICEA's President Rick Collins, who's going to talk a little bit about the value of writing a paper and submitting your abstract for the ICEA workshop. Those of you who are on the line, if you want to send any questions, now's a really good time. Rick?
Thank you, Megan. Good morning, good afternoon, and even good evening, depending on where you are. Thanks for joining us today. If you've been with us over the last 2 months now, listening to presentations that are based on papers that were written for the canceled San Antonio conference, you will have heard what I'm about to say. So if you decide to stick with me and see what other questions might come for the speakers after, great. If you want to tune out for a minute, great too. But I want to discuss and sell to you the value of writing a paper. So, if you are in fact fortunate enough to have an abstract accepted for the Minneapolis conference, I really encourage you to go the extra mile to write a paper. Very quickly, I say there's 3 good reasons to do it. First of all, it qualifies you for one of the coveted Best Paper Awards, and the recognition that comes with an award like that. It's fine to do a presentation, come to the conference and do a presentation, but you will not qualify for one of these awards unless you've actually submitted a paper. So that's number 1. Number 2, and I'd say equally, if not more important, the process of authoring a paper is going to be an invaluable learning experience for you, regardless of how much experience you've got. And I think it can be experience that, sets you apart from your colleagues. Frankly, the longer I'm in this field, the more convinced I am that effective technical writing is becoming a lost art. And I think an ICEA paper is a great opportunity to practice those skills. And in fact, the practice you get through writing a paper could help you writing memos, could help you writing emails, so on and so forth. So that's the second good reason for going the extra mile to write a paper. And then third and finally is you will have this paper will be available, readily available, not only to ICEA members, but to the general public by virtue of the fact that the ICEA workshop archives exist, and those go back 12 years or so. And so your paper will forever be there. If someone Googles your name, there will be a hit that shows your paper sitting there on the ICEA website. So please consider these 3. There are probably more good reasons to be doing this, but start early, gain some support within your organization. If you'd like to get a little bit of time on the job doing the paper, or like anything else that's good, it's probably going to require some work after hours on the weekend. But I know ICEA would love to be in a position to be consuming and considering your paper for a best paper award. And Megan, correct me if I'm wrong, but I think typically we've had maybe 5 best paper awards for specific tracks, and then one of those 5 or maybe 6 are selected as the overall best paper for the workshop. Is that about right?
That's right. We try to break the number of papers we've received into categories that are similar to each other so that we have about an even number of papers in each category.
Yeah. Thank you. So thank you, Megan. Thank you, everyone.
Well, thank you, Rick. I am about to unmute Matt Kiefer. He has a question. Matt, you're up.
Hi guys, thanks for the presentation. The Shiny dashboards look like a great tool to share and evaluate improving cost management. Oftentimes our analysts are handling classified data. And I'm wondering, are there ways to ensure information security when sharing data through these dashboards on R and Shiny?
So if you're working in an environment that lets you use the Shiny package, everything that you're going to be working with is going to be locally hosted, just like it would be if you were running some sort of R script. But of course, the challenge is there's some environments where you might not actually have access to some of those external packages to go build dashboards like Shiny dashboards.
Great, thank you.
Yep, no problem.
Cool. Well, I'm going to pause for just one more moment and actually say to Paul, Alex, Tyler, do you have any final thoughts so we can give our folks one more chance to send in a question?
No, just to say thanks again for having us and the opportunity to present the information. How about you, Alex or Tyler?
No, thanks for having us virtually present, and appreciate everyone's time and for everyone at ICEA that's made this possible. So thank you.
Thank you, guys.
If any of you attendees come up with any questions later, feel free to reach out to the 3 of us. You can email any of these email addresses you see here. Yeah, we'd love to talk more about it. We had a lot of fun putting this paper and presentation together, and we're always looking for more ways to share information.
Okay, wanted to make sure I didn't cut anybody off this time. Thank you, guys. If for some reason anyone listening isn't able to get the emails off the screen, you can of course contact the ICEA office at ICEA@ICEAonline.org, and we'll pass you along. Thanks, Paul, Alex, and Tyler for presenting for us today. Thank you, Rick Collins, for your thoughts on the call for papers deadline, which is, by Google calculations, 76 days away. So I hope all of you have a fantastic rest of your day, fantastic week. We'll be back next week, and I hope to hear all of you then. Take care and be good to each other. Bye-bye.
Thank you.
Bye-bye, thanks.